Sometimes we only need to know that an integral is finite or infinite. That is, that it converges or diverges. And we don't need to know the exact value. In cases like that, we sometimes can use the comparison test. So this compares two functions. F is the larger function, g is the smaller function. They're both non-negative. But if the bigger function, integral from a to infinity of f of x, converges, then the integral of the smaller function converges too. So if that bigger integral is less than infinity, then the smaller one is too. On the other hand, if the integral of g of x, the smaller function from a to infinity, diverges, so that has an infinite answer, then the integral of the bigger function f here also has to diverge. So let's look at an example and see how we can use this. So we want to show that the integral from 1 to infinity of cosine to the fourth x over x squared plus 3 dx converges. So it doesn't say find an answer, but just show it converges. So what we need to do to show this converges is overestimate it with a simpler function. So we look at this cosine to the fourth x over x squared plus 3. And we want to overestimate it, so less than equal. So we want to increase this fraction. So to increase a fraction, you can increase the numerator or you can decrease the denominator. Both of those make the fraction bigger. So while cosine x is between -1 and 1 always, so if you take an even power on cosine, it's going to be between 0 and 1. So we can overestimate the numerator with a 1. So this function will be less than 1 over x squared plus 3. And notice that simplifies the function quite a bit. So again, here what we did was we overestimated our cosine to the fourth of x. It is less than equal 1. And now we'll work on the denominator. We can decrease the denominator by getting rid of that plus 3. So this function will be less than 1 over x squared. We made the denominator smaller, so the fraction got larger. Okay, so we decreased the denominator. And then we know that the integral from 1 to infinity of this larger function, 1 over x squared dx, we know that that is less than infinity. That is, it converges by the p-test. P equals 2. And so that means that the integral of the smaller function, so therefore the integral from 1 to infinity of cosine fourth x over x squared plus 3, which is the smaller but non-negative function dx, we know that one is also less than infinity. In other words, it converges, and that's by comparison. Comparison to the larger function, 1 over x squared. So again, we don't have a value, but we know it's finite.